Hey everyone, this is a brief mini lecture on the law of sines. You may have heard of it sometimes referred to as the sine law, maybe the sine rule, or the sine formula. So the law of sine is used to find the unknown angle or the side of an oblique triangle. So we'll call an oblique triangle a triangle that is not a right triangle. So the law of sines should work with at least two angles and the respective side measurements at a time. Okay, so the law of sines definition. So we see it as sine A over A equals sine B over B equals sine C over C, or we can write it as side A over sine A equals side B over sine B equals side C over sine C. And of course, we're making a proportion, so you only need two ratios at a time out of the three. When we actually apply the law of sines, it can be used to compute the other sides of a triangle when two angles and one side is given. And it can also be used when two sides and one non-included angle are given. So let's take a look at this example. We know the value of one of the sides, which we'll call side A. It is 7 centimeters. And we know the value of two angles. We'll say angle A is 60 degrees and angle B is 45 degrees. So maybe in this example, we're asked to find B. All right, so by the law of sines, we know A over sine A is equal to B over sine B. All right, so now substituting in the values that we do know. 7 over A was 60 degrees. B is the unknown, what we're looking for, over sine of B, which is 45 degrees. All right, so next we'll have 7 over the sine of 60 is the square root of 3 over 2. And then we have B over the sine of 45 degrees is actually 1 over the square root of 2. Okay, so that takes us to the next piece. The next piece is creating 7 divided by the square root of 3 over 2 to be 14 over the square root of 3 equals the square root of 2 times B. Okay, and then the last piece is the algebra that we know about, which is just dividing both sides by the square root of 2, right, to get the B by itself. So therefore, B is going to be equal to 14 divided by square root of 3 times, that should say 3, times the square root of 2, which is equal to 14 times the square root of 6. All right, and we've just solved that example. Just to be clear on how we got through that, I want to take a look at these pieces right here, such as this one, right? 7 divided by the square root of 3 over 2. Well, we know that that can be rewritten as 7 over 1. That 7 is like 7 over 1. And when you're dividing a fraction by another fraction, we know you change it to multiplication and flip that other fraction. So we flip the square root of 3 over 2 to 2 over the square root of 3. And then you just multiply straight across, right? 7 times 2 is 14, and 1 times the square root of 3 is the square root of 3. And that's how we got this part. I'll show the other side as well. Same type of situation, right? B over 1 over the square root of 2. Well, you can rewrite this as b over 1. B is just b over 1. And when it's divided, one fraction is divided by another, you change it to multiplication, right? You do the keep, change, flip. Change it to multiplication, keep the first fraction, change to multiplication, and flip the second one. So it becomes the square root of 2 over 1. And you're multiplying straight across. Well, b times the square root of 2 is just square root of 2b, or b times square root of 2, however, whatever order you want to write it in, and that's over 1, which is just the square root of 2b, right? And that's what we had there. So your instructor may want you to work through it like this, using fractions as such, or your instructor just may tell you to go ahead and plug it into your calculator and come back with some decimal approximations for these signs. Okay, so the uses of the law of sines. Let's talk about this for a sec. So generally, it's used to find the unknown angle or side of a triangle. So it can be used if certain combinations of measurements of a triangle are given, right? If we have what's called angle side angle criteria, right? Given two angles and an included side, we can find an unknown side. And then there's angle side, right? So here, given two angles and a non-included side, to find the unknown side. So these two criteria, they're going to provide some unique solution, as angle side and angle side angle methods are used to prove the congruence of triangles. So then there's something called the ambiguous case. The ambiguous case. So in an ambiguous case, if in a triangle two sides and the angle opposite to them are known, then there could be three possibilities. So again, in a triangle where two sides and the angle opposite to them are known, then there could be three possibilities: that there is no such triangle, there are two different triangles, or that there is exactly one such triangle. All right, this is known as the ambiguous case, and we'll probably go into another video with examples looking at the ambiguous case. The applications for the law of sines in the real world usually have problems that deal with angles of elevation or angles of depression, right? The angle of tilt, things like that. Within astronomy, to measure the distance between planets or stars, and measurement of navigation also is something that's possible. Okay, let's look at another example. So here we have triangle PQR. P, Q, and R, labeled as such. So we know triangle P has an angle P which is 63.5 degrees. It has an angle Q of 51.2 degrees. We don't know angle R, but we do know side R is 6.3. All right, so we don't know side Q or side P, and we don't know angle R. I'll put those in red. All right, so let's say it says to solve triangle PQ and R. Solve triangle PQR. All right, so first we can calculate that third angle, right? Angle R. That's not too bad because we know all triangles have to add up to 180 degrees. So we can say 180 minus 63.5 minus 51.2. And that's gonna get us, when we crunch the numbers in the calculator, let's see, what do we get? My calculator gets me 65.3 degrees. All right, so now I have that angle R, 65.3 degrees. So now let's calculate the sides. So we can do 6.3 over the sine of R, right? Which is 65.3. And then we can do P, side P, over the sine of P, which is the sine of 63.5. Right. And then go ahead and work through this using some algebra. We could cross multiply if we wanted to do so. So let's try that. Cross multiplying. And that gets us 6.3 times the sine of 63.5 equals the sine of 65.3 times P. All right, then dividing both sides by the sine of 65.3, that's going to leave us with the P, right? Because the sine of 65.3 cancels out at the top and the bottom. 65.3 cancels out. So there we have P being equaling the 6.3 times the sine of 63.5 divided by the sine of 65.3. And just crunching that in the calculator, see what we get. And it should come up to about 6.21 is what I get. 66.21, and always include the units, which is centimeters. Okay. And then we can go even further, and now we have side P, we have angle R, and now we should go ahead and find side Q. So in a similar fashion, we can use 6.3 over the sine of 63.5, right, equals P over, I'm sorry, that should be Q. So we're looking for Q. So 6.3 over the sine of 65.3 equals Q over the sine of 51.2. All right, in the same fashion, just go ahead and cross multiply, work through that. Push pause if you want. It's just a matter of cross multiplying and doing the algebra in a similar way we did what was right above it. So this is a little bit of good practice. So push pause and then come back and see if our answers match up. Okay, and now working through that, you should have gotten Q is equal to 5.40 centimeters. So you've just solved the triangle. We have R is 65.3 degrees, P is 6.21 centimeters, and Q is 5.40 centimeters. So this was a quick mini lecture on the law of sines.